more of a recap on what we have learned in the past, as well as some details on the series and parallel circuits. All right. So we shall start the lesson in another 5 minutes time. In the meantime, do join the Nearpod link as I shared in the Zalo and Zoom now. All right. So we'll start later in around 4 minutes time. All right. Thank you very much. Right, for those who just joined, do check on the link at the chat at the chat conversation section of Zoom, and join us on Nearpod. All right, we will start the lesson in another 2 minutes time. So, yep. For those who joined the lessons, please log into the Nearpod via the link shown in the chat. Let's give it 1 more minute. All right. So let's start. Welcome to We Love Science Advanced Lesson 7. We're going to talk about electricity. All right. So let's carry on. So we are going to recap on what we have learned in the past. So a short introduction on what we have learned in the past. Electricity is all around us, whether is it on our bedroom lamp, our favorite gaming PS5, iPhone 14, or the fridge that holds all of our favorite snacks. We need electricity to power them all right? So in life now, we almost cannot live without electricity. So if now, to the extent now, we have talked about it power our cars, and electricity takes many forms, like from coal, water, solar, wind, and nuclear, hydro, and okay. So now have you wonder how electricity goes to our house? We mentioned about electricity is made from two different sources. One is renewable, the other one is non-renewable. And electricity is made out of atoms. So to understand electricity, we need to understand the basic information about atoms. All right. So we have gone through this right in the past, whereby atoms is like small little particles that at the center of the atom is a nucleus, that the nucleus made up of protons and neutrons, and electrons revolve around them. All right. We will talk about how electricity works, whereby electricity works and travel in closed circuits, and it has to be a complete path before the electron can move through it. For example, when you turn on the light by flipping a switch, you close the circuit. When you close it, the current can flow through, and that's how your light bulb get lighted up. But if you open a circuit, the circuit can open, no current flow through, the light bulb cannot light that up. All right. It's the same concept as you watch a TV or washes your clothes in the washing machine. All need electricity, whereby it's going to travel from the power socket through the wire to power them up. All right, as mentioned earlier in last few lessons, in the last series, we have code wind, nuclear for electrical energy. And then we have electricity being generated from the power supply, power station, and sun, and it delivered from the power station through the wire grid all the way to your house. And in our house, we have these two different form of electricity maker, and today we are going to look more in depth on these two circuits, series circuit and parallel circuits. What is a series circuit? A series circuit is made by connecting the end of one device to the beginning of another, like this. So everyone stay on the same wire path. This is called series circuit. For parallel circuits, in parallel circuits, we have two different pathways for the current to flow through. So it can be connected to one, then at one time, it will basically split itself into two parts and go into two different light bulbs and back to the battery again. All right. So some question to ask: how does resistance function in a series circuit with multiple resistors? All right. So let's get started. Before we begin, I want to check with you one thing. What is the standard equation for calculating voltage? In the previous series of We Love Science, under the topic of electricity, we actually discussed and talked about how to calculate voltage. So can anyone give me an answer on how to calculate voltage? Let me see the answer on your screen. Anyone want to share your answers on the Nearport? How do you calculate voltage? Remember the triangle bar that we actually discussed in the previous series of We Love Science, whereby it's Ohm law. We calculate voltage by basically, right, to find out voltage, right, we basically use the formula called V equals to I, which is ampere, times R, which is the ohms, or shall I say the resistance. So to find out the voltage, we use the formula V equals to I times R, whereby V is voltage, I is more or less the current, or shall I say the ampere. All right, then we have the R, which is the resistance. All right, this is how we find the answer for this. All right, next questions. All right, by a show of hands, have you or someone else ever blown a fuse at home? Did everything stop working, or just some power points and appliances? Do share with me your answer now. When someone blown a fuse at home, did everything stop working, or just some power point and appliances? That means that, is it the whole house stop working, or some part of the house stop working, but the others still can work? Okay, I saw someone says that everything stopped working. Some say only some stop working. So all right, I still got some people have no answer yet. Maybe with the rest, I'll give them 1 more minute to answer the questions. All right. So if a fuse blown out, what happened? Did everything in the house stop, or only some part of the house stop? Well, the correct answer is basically, right, what happened when the fuse is blown? How do we know what happened? So what happened actually? Basically, right, when the fuse is being blown, right, all lights, outlet, appliances that is powered by the circuit will go dead suddenly. All right. There's no way you can on or turn on the light if the fuse at the circuit there goes dead, being blown. All right. Depends on which part of the circuit. All right. Let's carry on. So now, let's think on these questions. Consider a set of Christmas lights connected in a series. If you were to pull out one of the bulbs in a strand, what happens? What about a set of Christmas lights connected in parallel? So basically what I'm trying to say is that if let's say we have a Christmas light that is basically all in one straight line. So we have this light bulb. We have all the light bulbs like this: 1, 2, 3, 4, 5. Okay, example 6. Okay, example. Then we have battery. We have battery here. We have a battery here, like this here. If let's say compare this versus this, okay, now question, I got 2 different circuit now. One is in a series, one is in a parallel. All right. The question is, what happened if you pull out one of the light bulb? what happened to the rest? Does the rest still light up in parallel circuit? Yes or no? Or in series circuit? Yes or no? For this question, right, basically, as mentioned earlier, in order for the electricity current to flow through, it must be a closed circuit. Means you cannot take out any of the light bulb here, as there's only one pathway. If I take out one, this is not closed. The whole thing cannot light up because it's not closed. All right. But if I will take out this one, these two will still light up because the current can still close via here, just that it won't pass through here. That's why it's always best to align in a parallel circuit so that to minimize the chances of all light bulb not able to light up. All right. Having said that, let's move on to the next slide. All right. Okay, I shall carry on to the next thing. Let's watch some video about series circuit, and we will ask you some questions based on the video.
In this video, let's take a look at a series circuit. A series circuit is a circuit in which there's only one path for current to flow. We have basically a simple circuit here, a series circuit. We can visualize from the power source back down to ground, there's only one path for power to flow. This is a simple bulb. We could also add a second bulb into this and put these two bulbs in series with each other. So we could come into this bulb, go through the bulb, come out of the bulb, and right back through another bulb. So you'll see the current's going to go through this bulb and through that bulb and then back to ground. This is called a series circuit because there's only one path. Actually, every component in the circuit is series to each other. This fuse is in series to these bulbs, so it means all the current through each bulb is going through here. And we have a series circuit. Let's go live here. Anywhere along the line that I have an open, the circuit goes dead. That's because there's only one path. And so that's a rule of a series circuit, is that anywhere along the line that I have an open, it's going to kill the whole circuit. Now, another rule of a series circuit is that, and it's based on Kirchhoff's law, is that the voltage applied across the circuit, this whole is called source voltage, will be dropped across all the components. And voltage drop out here on the circuit is a result of current flowing through resistance that produces voltage. You could actually calculate it just like Ohm's law. E is equal to I times R, or voltage is equal to current times resistance. And let's actually take a look. Kirchhoff's law says that all the voltage drops will add back up to the source, and it's going to be proportional. Now, basically the only two loads we got on the circuit are two marker lights. We do have a switch and a fuse holder, which would probably drop a little bit of voltage, but I think it's going to be insignificant in this case. Let's take a peek here. In this case, we're going to use our meter. It's a voltmeter for right now. So I'm going to look at the voltage drop across this one bulb. In this case, I go to COM port. Now, all these wire colors don't matter, so that don't worry about that. We'll use COM port and in our volt port, DC volts. And so the way this would work, the perfect way to do this would be to realize or to recognize that current, or conventional current theory, is that current flows positive and negative. So as current's flowing through this bulb, the lower potential is going to be downstream of the bulb. It's kind of like water flowing through a hose. If you partially block the hose, flow slows down, a high pressure above the kink, low pressure below the kink. Same thing here. Think of current flowing through here. There'll be a higher voltage potential here than here. So if I put my red lead, or the lead off of the positive on that side of the bulb, and then go on the ground side or the down side with my COM port, I'll get a positive number here. There won't be a negative sign here. If you got these two wires reversed, you see a little negative sign. You'll have the same number and will not cause a problem as long as you're aware of that. Now we look up here, 7.07, so it's round off to say 7 volts. There's big V, no multipliers, so that is in fact 7 volts. Now, we'll also be dropping voltage over on this bulb. So let's move over there. We'll just move a meter over here, and we'll go upstream and downstream, and we find 6.75 roughly, or 6 3/4. Now these two marker lights look identical, but in reality they're made on production line, and the filament resistance will vary, and that's what you're seeing. Is the reason it's not exactly the same number, which would be half of the source voltage, is because the variance in the resistance of the filament. But the bulk of your voltage that's applied to the circuit is being split across here. If you swing up here to get source, see if you can pull that off, go from here all the way to here, and we got 13.8. And so the idea is the source voltage, the voltage applied across a circuit, will be dropped across all the loads. In this case, 2 loads. Where this happens though, sometimes you may have, say, a bad fuse holder. You could drop, say if it dropped a volt here, it would kind of rob that, and what's left down here would be split. So voltage drop, we talked about a lot in these videos, is a very important diagnostic tool, very, very powerful way to find resistance. So in a series circuit, we can add up all the voltage drop, equal source voltage. Current's the same everywhere. Let's take a quick look at that. So I'm going to come out of here, and we're going to change over. This little more room over here, it looks like. And let's change over, look at current. So we'll swing over here to the amp port, the COM port. If you're using a Fluke 87, you may hear this on the video, there's chirping. It's chirping because it knew you plugged into the amp port, but you don't have the amp port selected here. So just go move over to amp here, and the chirping stops. Now, a rule of a series circuit is the current's always the same everywhere in the circuit. And we could prove that by we could just come here and we could come out of the very top into our ammeter. Now remember, we now have a series relationship. And so the current comes into the meter, back out of the meter, and into the project. Now I'm showing 177, small m, 177 milliamps. Now this is pretty low current because we have 2 marker lights, and the 2 marker lights are also wired in series, which drops the current to half of what it would normally be. That's one reason that lights are so dim right now, is that they're running half voltage or half current also. So we notice 177 milliamps, basically 0.177 amps. We could come back and come over here. There's a 177 or 176. To come way down here to the bottom, coming out of the bottom of the project on the way to ground, and we get the same number. This proves that in a series circuit, the current is the same all through the circuit. So if you're doing drills here for the school, and you're told to check the current in a series circuit, it doesn't matter where you put the ammeter, but anywhere you want to, because the current's the same. That's a wrap for series circuit.
All right, what we have just seen, right, is a demonstration of a series circuit. All right, now moving on to the next slide. So this one open-ended questions. How do the voltage drop across the 2 light bulbs in the video relates to the total voltage drop for the entire circuit? For this, I will let you answer at your own timing later using the student pace link. All right, let's carry on. Now we move on fully on elasticity and circuits. As mentioned earlier, there are three particles that make up an atom. They are called the protons, which is the plus sign, the neutron, which is the neutral, and electron, the negatives. All right. So, which subatomic particles can move from one object to another? The answer is electrons. What does the addition of electrons do to the charge of an object? The adding of electrons to an object will always make the object become negatively charged. But if you were to remove electrons on the charge of object, the object will become positive. Same thing here, we have a balloon and your hair. I'm sure you guys played this before. So how does charges interact? The plus minus, how do they interact? It works like magnet. For magnet, North Pole and North Pole repel. North Pole and South Pole attract. Same theory here for charges. The charge, when the two objects the same charge, positive and positive, it will repel. When the two objects with different charges come together, one positive, one negative, together, they will attract. So what exactly is an electric current? The electric current is basically means the continuous flow of electric charge through a material. As long as this particular material allows the flow of the electric charges, is called electric current. How do we measure current? We use the formula, the SI unit called ampere, A or AMPS, which is used to calculate the amount of charge flowing past a point in a certain amount of time. All right. There is also one thing called potential difference in the electrical current. Before let's look into potential energy, PE. What is potential energy? Well, on a let's refer something example to a roller coaster. Which part of the roller coaster has more potential energy? That's obviously when the roller coaster is at the highest of the track, right? So the same as the electrical current, the charge in a current is like a roller coaster car. The track of a roller coaster is like a wire. The motor that gets the car to the top of the first hill is like a battery. So we can relate electricity current to potential energy using the example of roller coaster. So what exactly is the potential difference? The potential difference, right, is basically those are the difference between the two location potential energy. One example, let's use back the roller coaster. The difference between a roller coaster and an electrical current is that the potential difference is caused by the difference in electrical charges in two locations, not height. For a roller coaster, the higher you go, the more potential energy you have. Whereas for the electric charges, it's two different locations instead of high and low. All right. So students, always remember this statement. Electric charges will always, yes. All right. So will always flow from a region of high potential energy to the region of low potential energy. All right. When the charges reach the positive terminals and enter the battery, it gains electric potential energy as it travels through the battery to the negative terminal. All right. Now let's look at another term called voltage. So what is voltage? Well, it's another term for potential differences. What is the unit used to measure voltage? It is volts. V. So in a 9 volts battery, when an electric charge moves from the negative terminal through the battery to the positive terminal, how much potential energy does the charge gain? Well, since it's 9 volts, right, the answer will always be the same as the number of the battery volts, 9 volts. A 9 volt battery, the movement from negative terminal to positive terminal will always be 9 volts. All right. Now let's look at some of the basic circuits. All right. A circuit is a path through which electricity can flow, like this particular circuit here, a battery and a light bulb. All right. Most circuits have 3 different parts. An energy source, like battery, one or more loads run by electricity, conductors, wires that connect the 2 things. All right. So this is a very basic diagram of a basic circuit. All right, let's carry on. And then we have one thing called the energy source, as mentioned earlier. So why do we need energy source? Well, a circuit needs an energy source, right, to push a charge through the circuits, like battery. All right, the load is something like a device, as mentioned in the earlier slides, that operate using electrical energy. One thing, for example, is light bulbs, where we always use light bulb as a form of example, where we talk about circuit. Lastly, the third part is conductor. A conductor is a material that allows electrical energy to flow through it. For example, copper wire and any other good conductor of electricity materials. That is a conductor. All right. We have one thing called a resistor. So what is a resistor? A resistor is an object added to a circuit that restricts the flow of electrical energy. Basically, in short, it basically slow down or inhibit the flow of electric current by producing a voltage drop when a current passes through them. They limit the current and cause some electrical energy to give out as heat. All right. We have another thing called the switch, whereby it used to open or close a circuit by controlling the flow of the current. As for example, your room, your light, you have a switch to turn on and off. When you switch on, means the circuit is closed. When you switch off, the circuit is off. So let's do something. Let's imagine a diagram in our mind. We add a switch to the basic diagram of a bulb and a battery. Let's imagine what will happen, right, when you open and close the switch. All right. And when an electric current reaches an open switch, the current stops. Why? Because cannot pass through anymore. It's got jammed. This creates an open circuit because the switch is open. There's no way the current could flow through here. It will always stop at here. So that's why the current stops. And this is known as open circuit. When the electric current reaches a closed circuit, the current continues to flow here to here, from here to here, because it's closed. Therefore, this creates a closed circuit. All right. Next, as we discussed earlier, there are 2 types of circuit. One is a series circuit that provides one possible path for the current to flow. As much as the current don't like it, they like it or not, they have to travel in one direction only, one path only. Whereas for parallel circuit, they have the rights to choose any way they want to go, as long as it's one direction back to the battery. All right, so parallel circuit offers more than one path for the flow of electricity. All right, let's look at the series circuit in more. Just on the video, it mentioned that a series circuit, the loads are set up in a series or one line to flow that require the current to flow through one load before passing through the next load. All right, if you have a paper and pencil, you can draw this diagram down and basically indicating that where the current flow from. All right, the current will flow from here all the way to here and back to the battery itself. All right, this way, this direction. All right, so it will pass through light bulb 1, then followed by light bulb 2, then light bulb 3, all the way back to the battery to close the circuit. Next up, if we were to disconnect one of the light bulb in the series circuit, because there's only one path for the current to flow, where there's a break in the pathway, this will stop the flow of electricity. And even though one light bulb is taken out, the rest cannot be lighted up because there's an open circuit. All right. Next one. All right. So what happens if you were to reconnect back? All right. We can reconnect back because when we reconnect back the light bulb, the series is closed. Therefore, all the light bulb can be lighted up because the current can flow through every single one of them. All right. Then now we look at parallel circuit. All right. For parallel circuit, each load has its own path. You can see here we have plus minus sign. Each load has its own pathway. Flow through here, back to here, one round, back here, one round, and back here. All right. Therefore, all the wires, the current can flow through. All right. If you were to disconnect one light bulb from the parallel circuit, the other light bulb will still work because it's in parallel, and even though it's opening here, the current can still flow in the other direction and complete the circuit. It is very, for parallel circuit is often used in houses because a parallel circuit provides more than one path for electricity. Therefore, by having a parallel circuit at home, one part fail, the other part can still use and work. All right. Why does the, as we said earlier, why does the light bulb continue to light? Because the load in a parallel circuit do not share the same wire path. Therefore, it can still be closed. And but however, one thing is right, the brightness of the bulb will be affected. Why? Because each load is being separated. That's why the brightness will be affected. By brightness or dim depends on the voltage itself. All right. Next one. Now, for series and parallel, let's imagine in our mind what happens if we add more load to the series and to the parallel. Which one will be dimmer? Which one will be brighter? I give you 1 minute to think about it, then we can share the answers together. All right. All right, as mentioned, yes, I saw some chat coming in. So which one will be brightest? Which one will be dimmer if you add more load in the circuit? I saw some answer coming in through the chat. Well, someone say parallel will be the brightest. Someone say series will be the brightest. So which one actually will be the brightest? Keep your answer coming in from the chat. Well, okay, next one is parallel. Parallel. Okay. Yeah, I saw someone say parallel won't last long. as parallel won't last as long as a series. Okay. All right. So what actually happened to the brightness of the bulb that's connected to a series circuit when we add more light bulb in the series circuit? Well, the brightness of the light bulb in a series circuit will get reduced because the total resistance of the bulb will increase and the current therefore will decrease. Therefore, the more light bulb you basically add to a series circuit, the dimmer the light bulb gets. All right. So do not add more load on the series circuit. Whereas for the parallel wise, let me see the answer on the chat. The parallel say that some say that the parallel is brighter because it's different pathway. Okay, yes. So you added load to the parallel, it will maintain its brightness, but it will not last long for the parallel circuit. All right. So remember that everything depends on the battery. The more battery you put, it may become brighter until the light bulb get burned out. So if you want to add more light bulb, you can try parallel circuit instead of series circuit. Because the more light bulb you add for series circuit, the dimmer it gets. All right. Now, let's draw now. All right. For this finale, I want you guys to draw a circuit with 4 batteries, 3 light bulb, and think of a circuit that when one of the light bulb bursts, the other 2 can still work. So students, you have 10 minutes to draw, or sorry, 5 minutes to draw. 5 minutes to draw a circuit with 4 batteries and 3 light bulbs, so that if any one of the light bulbs bursts, the other 2 can still work. All right. Okay, so I'll give you 5 minutes to draw this. Okay, for those who just joined, I have sent the link on the Zoom. You can join the Zoom session. Yes, Lily. Any questions, Lily? Yes. Hello. Any questions? No? All right. Okay, you guys can think of, you can draw either series or parallel, but my question is, I want you to think of a circuit whereby if one light bulb bursts, the other 2 can still work. All right. So you can draw series or parallel, but I want you guys to draw a circuit when one light bulb bursts, the other 2 can still work. Okay. So I didn't mention series. I didn't mention parallel. Yes. Milan.
I have like draw my drawings, but in a bit of like a scientific way. So it's my hard for people to visualize it.
No worries, it's okay. Just draw whatever thing you can picture it. Because my question is, draw a circuit that with 4 batteries, 3 light bulbs, so that if any one light bulb bursts, the other 2 can still work. If you know how to draw in a series, you can draw it. If you know about parallel, also can. The main thing is use your imaginations and the knowledge that you learned, and you propose me a circuit with 4 batteries, 3 light bulbs, and the condition is if any one of light bulb bursts, the other 2 can still work. All right. I saw Peter has submitted a parallel circuit. Okay. We have Shawan is still doing. Alicia have completed. We have robots. Wow, robots. That's drawing a very nice diagonal, diagonal circuit. We have ghosts. Doing very well done. 3 light bulbs is circuit. All right. Take your time, slowly and do. We have more than enough. We have James completed the circuit already. Well done. Today's lesson is more about recapping what we learned in the past, as well as how you draw a circuit or how do you propose a circuit when somebody gives you a requirement. Like in this case, I give you a requirement, 4 batteries, 3 light bulb. 1 light bulb spoiled, others 2 can still work. So you are the architect now. You are the architect. You must propose to be a solution. Yes, Mian.
Can like you teach everyone like how to draw in the scientific way if possible, because this place like for kids to draw.
All right. Okay, you can look at my screen now. So how do we draw the scientific way of a circuit? All right. But before that, I think some of you are still doing right. So I think then you guys finish first. In another 2 minutes time, I will teach you all how to draw. All right, now 2 minutes time, I'll guide you all how to draw the diagram. I won't say the scientific way, I'll just say the diagram. Okay, I see majority are submitted. All right, let me just start by drawing now. Okay, first of all, right, to draw a battery, right? Battery will always be one big, one small. One big, one small, one big, one small, one big, one small for the batteries. All right. Why is there a one big, one small? Because the big one, the big one is basically the positive, and then the small one is the negative. All right. Next, we will draw the wire that depicts the current flow. My question is, everyone look at my screen. My question is, 4 batteries, 3 light bulbs, and any one light bulb bursts, the other 2 can still work. From what we know from a series circuit, if one light bulb bursts in a series circuit, the other 2 will not work. So hence, as a person who studied this chapter, I cannot use a series circuit. Instead, I must use a parallel circuit. So I will first draw the, let me draw the outer layer first. Let me just get an eraser first. I think I draw 2, I will say I draw 2 not straight lines. All right. Okay. So now I got 3 light bulb, right? So I will just give 1 light bulb in every line, in every parallel. So to draw a circuit diagram, we use a circle and a cross to represent the light bulb. All right. So as mentioned, I got 3 light bulb, 4 batteries. All right. So now let me just close the circuit now. I have 1. I have 2. I have 3. In this case, for a parallel circuit, no matter which light bulb bursts, I have the other 2 that is actually still working. Why do I say so? Because the electricity current will flow from here to here to here. When it reaches here, it goes 2 directions. Then back to here. Same thing, 2 directions here. And back to here. Then flow here, 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 and it flows together here. Flow here, here, here. So example, if one of the light bulb spoiled, if this light bulb is spoiled, I still got here to complete the circuit and here to complete the circuit. That's why this parallel circuit is the best diagram to answer these questions. All right. Let me see your drawing now. We have Ghost who submitted a parallel diagram. All right, well done. Share it to everyone. Okay. Then we have next, we have other drawings. Let's say we have, this is quite nice. We have many artists here, but the correct diagram way should be this one. All right. Parallel circuit with 1 light bulb on each. All right. With that, we have ended today's lessons. I will send you the link later in Zalo for you all to do a student pace. All right. So that's all. I will see you next lesson. Yes.
Bye.
Bye-bye. So I'll see you next week for another lesson on the Ohm's law.
See you next week.
See you next week. Bye-bye. Take care. Bye.
Bye. See you next
Bye, Andrew. See you next week.
See you next week. Bye-bye.
Đợi chị Trúc, đợi chị. Bye. Rồi, bye tụi con nha. Yeah.